I'm Liam Spradlin. I work at Touchlab and on various other things outside of Touchlab. And this is Francisco Franco.
Hello, everyone. My name is... Hello. Okay. Hello, everyone. My name is Francisco. I'm an independent developer, and I work on various apps and kernels, and I'm helping Liam to make this thing come true to life.
So today we're going to be talking about mutative design and specifically what's new in Project Phoebe. So I always ask this, but before we get started, I want to see if anybody in here has heard of mutative design in Project Phoebe. All right, awesome, more than usual. But for those who haven't heard of it, I'm still going to run through kind of a brief overview of what it is. I've sprinkled in the new stuff here and there. So those of you who have seen me speak about this before probably recognize a lot of this material. But just to get started, we're going to define what mutative design actually means. So this is a theoretical design methodology for interfaces and experiences that are kind of born with, live, and evolve according to users' reality. And what do we mean? Well, first of all, before we kind of define what that actually means, where are we now? So one of the main applications that I can think of for mutative design is accessibility, because where we are now with that is there is some great accessibility guidance. And as we learned in the keynote today, there are great ways to make sure that you're building an experience that isn't just accessible, but inclusive from the very start. But unfortunately, existing implementations are too often only partially implemented, or accessibility is left behind entirely. And again, as we learned today, accessibility isn't just a thing that a certain group of people needs. It's about everyone and making inclusive experiences, because we all have situational limitations, whether you're driving and you can't focus on your phone to see detailed information, or you're out in bright sunlight and your screen doesn't get bright enough to let you see that text that's exactly at 4.5 to 1 contrast ratio, things like that. So it's just something that's important to everyone, and I think there's a lot of room to improve from where we are now. So Project Phoebe is a first open source step towards that goal of mutative design. It's comprised of open source samples, including sample apps and design assets, and research, theory, and community for discussing this idea and kind of getting this to come to life in actual things you can use. So today, first we're going to define just some terms that kind of relate to users when we're thinking about mutative design. So 3 really basic ones are behaviors, characteristics, and user reality. So I define them kind of using this funky chart just to like visualize how I think of these. Behaviors are kind of like sporadic. They could be repetitive. They could happen only once. They could happen a couple of times. And characteristics are more like ongoing long-term things that are kind of ongoing realities for the user. And the user reality is all of those things combined. So it's the full picture of who the user is from start to finish. So first we're going to talk about the mutative user journey, and then we'll get into kind of how mutative design impacts the design process and how it impacts developers. So first, we have to get to know the user. So we can't really change the interface to significantly suit each person if we don't know who they are and what their needs are. And there's some ways to do that are really easy to illustrate. And one of them that I go to is measuring touch acuity on a screen. So to the user, the visible touch target inside the app right now is this next button with an arrow. So they see the blue text as the thing that they can touch, and that's what they're going to be going for. So that's what it looks like to them. But the actual touch target is bigger than that. So the app knows that if you touch anywhere inside of that, you're probably triggering the next button. But if we were trying to figure out if users were having a trouble with dexterity of pressing specific buttons, we can nest those targets and measure over time how far away their touch imprint is from the visible target, and then make adjustments as needed for that. And so once we kind of know the user, if you've been using a mutative platform for a while and you've used a lot of apps, then it probably knows a few things about you. So when you open a new app, it will have a starter state, which is ideally the app's attempt before you even run it to accommodate for as many of these characteristics and behaviors as it knows about from the platform from the get-go. So you don't have kind of a learning curve for every single app. It mixes in those changes from the start. And then after that, of course, is continued mutation based on how your realities change, what behaviors or characteristics you display, things like that. So to kind of explore this idea in one of the first publications that I did about Phoebe, I randomized some users with a given set of characteristics or potential characteristics that people could have and values for those, and just kind of randomized 2 users for a couple of different sample app designs. And the first one is a contacts app. So you can see we have just the basic list of contacts. There's a carousel up top for your favorite or recent ones. There's a floating action button for creating a new one, and a search bar, and on phones you have a dialer tab as well. And the first user that came out was an adult who has full physical input but is low vision. So the starter state for that scenario might look something like this, where we've just increased the contrast to enhance it that much further for that person. The text size is automatically larger, although this can be adjusted on the system level. Icons are also larger, but keep the same kind of dimensions as the rest of the interface elements and things like that. And to just explore like some continued mutation, we might find based on behaviors that the user, although they're able to access all parts of the interface, they might not know exactly what to do next. We might find them like idly swiping around or not really taking action, or not really kind of accomplishing the defined goals for the interface that the app has. So in that case, there are things like progressive wayfinding where we would highlight kind of the next steps for that person. The second user, this is just a fun animation showing the starter state for this one, but the second user ended up being a toddler with full vision and physical input who has no data access but is relatively familiar with tech, which is a totally subjective and contextual characteristic. But how would we get to the starter state for this person? So I found, just doing anecdotal research on the topic, that toddlers who use mobile devices, first of all, the touch input metaphor is much more intuitive for a lot of young children now than actually other more classic input types like mouse and pointer, which makes sense, especially if the touch input has very visible feedback. But that being said, young children are still prone to fast, imprecise motions that won't really hit the targets very accurately. So in this case, we've expanded the list to bring those touch targets further apart. Again, with the wayfinding, the floating action button is larger and easier to hit. It's more brightly colored. And along with the search bar, that key action has been added. And since there's no data, we're not searching for places, we're just searching contacts locally. And when this user came out, I asked myself, why would a toddler be using a contacts app? But one of the cool things about the idea of mutative design is that we don't really necessarily need an answer to that question right away. We just need to know how to accommodate that user based on their characteristics. And so that's kind of what the starter state looks like in a static form. But the toddler user is an interesting case because as they develop and are able to more precisely accomplish things in the app, it might actually return back towards that original mother design. So how does that impact the design process? I'll talk about mother design, which is kind of the original design for the app before it's changed, and Selene, which is a sample app that we built together to demonstrate a couple of really simple mutations. So going back to this, this is the mother design for the 2 example users that you just saw. And basically what that means is this is the design that you make as the designer and the developer as a starting point. It's kind of the archetypal design, and this is where you want to define all of the components that will exist in the app. So mutative design doesn't necessarily mean that like new things are going to be appearing or things are going to be moving all over the place. You still have to respect the notions of muscle memory and visual hierarchy and users feeling confident in using your app. And that's where you establish all of this. So you want to establish as much of that as possible right here in the mother design. And of course, the user may never see this because it may accommodate them before they even open the app. And it's just the foundational UX for the experience. So Selene, this is Selene. It's a basic notes-taking app. that we built just as an example. You've got a main screen with a list of notes, a tab for past, present, and future, which corresponds to archived, stateless, and reminder notes. And then you have the note screen with the title, the note text, and the ability to archive, change the color, or set a reminder. And the first mutation that we implemented here was the contrast mutation, which reacts in real time to ambient light around you using your phone's light sensor to enhance contrast when you enter situations that might be limiting in allowing you to read the content on the screen. Because while the original colors might meet contrast guidelines, they might not be visible because your phone screen just doesn't get bright enough to overcome the sunlight. So this at least gives you a good chance. So we're going to look at how we designed that. We started off with Mother Palette. This basically represents every color that's possible in the app initially, before anything changes. And then we experimented a lot with how the screen appears when you enter bright light or difficult lighting conditions. And basically, just to walk through what we found, it's pretty obvious, but when you enter bright light, black text becomes gray. A gray background will turn lighter gray. Gray text will get even lighter and unreadable. And a black background with light text actually had the best chance of maintaining that perfect contrast when you were outside because it only becomes dark gray when you enter sunlight. So, but that doesn't mean that we should trend all of the colors towards black because that defeats the purpose of having the palette in the first place, which is to kind of categorize your notes and make it easy to glance at what kinds of things you have. So we had to kind of set a lower bound for this and determine the darkest point for each color that would still be recognizable in most lighting conditions while also enhancing contrast when it's needed. And then the second thing that we have is behavior-based onboarding. And I'll just show you quickly what that is. Basically, this is when you first enter the app, there's an empty state with no notes. You have a floating action button to create a new note. But if we find that the user is using the app for the first time or they don't have any notes and they're just kind of hanging out there not knowing what to do, then the floating action button makes kind of a visual transformation into this full width button that has a much more explicit label. And then once you successfully accomplish that action, it will animate back to let you know like this action is in fact this button, and users can do it successfully in the future.
The first time we did this, we had the timer for like 10 seconds. We tried for 5 seconds as well, but after some testing, we found that 7 seconds was mostly the best wait time for changing the button size, and it's not just distracting, and you right away notice exactly what to do. So I think we achieved that.
Right, and it will depend on every app too. Like if you were implementing this in some apps, you know, sometimes users are very impatient. If they open the app and they don't know what to do, they might just uninstall it, or they might hang around. It depends. And a lot of users are curious enough to press this button. So it's just a simple example, but it could be behavior-based onboarding could be much more complex than that. So now I want to turn it over to Francisco to talk a little bit about developing for mutation and like what kinds of things he has to think about.
Okay, so I was paid to not say that this isn't hard, but the first steps into this, for me, they were harder than it seems, because I'm not used to, at least for myself, I'm not used to think about changing everything on the go, especially views, colors, and but after getting into it, it was actually much easier. We spent a long time discussing different theories and different ways to go into this, and we thought that using the light sensor on your phone, because everyone has a light sensor on your phone, and Android has a pretty good API for this, we thought that it would be a good idea to tap into that. After that first barrier was taken down, the hardest part, I think it was finding the right values for the right calculations for when you receive a light value from your device, because sometimes some device, for example, Google, the Nexus phone, the values are correct and they are pretty much consistent. If you use another device like Samsung something and the device might be differently calibrated, the values will be different and something will be not crash, but it will have different, very different colors. So I think that was probably the hardest part. But So I guess now we will show you. No,
Yeah.
not now.
So we'll take a look at how the contrast mutation actually works. But before that, I want to introduce Gaia, and how basically this whole section is about how do we know that mutation works? How will we learn from the users, and how will we know that the changes that we're making are intelligent and useful and actually helping them accomplish something? And the first step to that is Gaia, which is just the name we're using for basically mutation as a platform. And the reason for this is, first of all, mutation must happen automatically. So if we, as designers and developers, are always deciding by ourselves what mutations should happen and exactly when they should happen, then we're actually just doing a more complicated version of our existing process and not really solving the problems that mutative design seeks to solve. So in the bright and magical future, Gaia would be a platform, a part of the system, that essentially brokers information between itself and the apps. It would contain instructions for all known mutations and the characteristics that are tied to those, as well as how to recognize those characteristics. So an app might define to Gaia its existing components and their goals, and then Gaia would say, do I know an answer for this situation? And if it does, then it would send it to the app. But that's not how it works right now, because I haven't convinced Francisco to start an Android fork with me yet. But we can explain how it works in Selene.
Yeah, sure. This is just a sample code of what I've done for this. So, for example, it would be kind of hard to reach everyone. But first, we get the light sensor value from Android, and then we calculate based on that value the light value on the color. And then based on that, we apply the background color, for example, for text view or floating action button, based on the magical calculation that we came up with, and just apply to it. And obviously, we have some time differences because we cannot be applying this every millisecond because performance issues and whatever. But yeah, I think this code is open source, so you can check it out. I think it's pretty much it. Everything is animated as well, so it's pretty. But it's pretty simple in this example.
Right, and so the timing thing is important. That's something else that we had to do a lot of testing with because it's completely possible, and in fact, we tried it to change the color in exactly real time with the light changes, but it becomes very overwhelming and unpredictable.
Yeah, and the more views you have subscribed to this, the more performance heat you'll have, because it's not just making the calculations, but then doing the animations and applying everything on the main thread. So it gets, and you imagine you're scrolling at the same time, so it may get a little janky. So yeah, we had to be a little bit intelligent with this, or try to be at least. But yeah.
Yeah. So so basically, views can subscribe to this very limited, small implementation of Gaia. But you can imagine how extrapolated out, once it becomes part of the system, an app could subscribe to this thing in the system and have mutation as a platform rather than figuring it all out for every single app on your own. So to continue talking about how we know if it works, I want to just lay out 3 principles of mutation so far. And of course, all of this is a work in progress. But so far, I think that mutation should happen over time, not in great leaps. And what I mean by this is that essentially, if you extend the metaphor to its breaking point, your interface should not lose an arm and grow 3 eyes between 2 times that the user is visiting your app. Things ideally should happen imperceptibly, and the user would only have an underlying experience of increased success with apps over time, rather than noticing that things are just changing all the time. Second, mutation should balance impact with perceptible change, and that goes to what I was just saying. You should seek for the highest amount of impact for the user with the lowest amount of perceptible change. And mutation should only happen in response to real and ongoing needs. In other words, it should only happen in response to characteristics of the user and not things that we want the user to do. So we aren't, the goal is not to manipulate the user into using a new feature or click on a new button. It's to help them succeed in the tasks that the app has in an impartial way that just allows them to be included in the experience. So knowing that, success means, first of all, satisfying all three of those principles. Second, it means quantifiably improving the user success in relation to goals, which means that you have to determine goals. And there are two ways that I can think of defining goals. For the first is passive acceptance of instructions. So if you think of system components like buttons and text inputs and things like that are very basic to every experience, the apps could just passively accept these, knowing that the goal for a button is to press it, or the goal for a text field is to enter text, for instance. But there could be active requests for goals, like if a password field exists, then you want a password. Maybe they're trying to type something else in there. Maybe they need to hit things in a certain sequence, things like that. There would be explicitly defined goals rather than just accepting instructions. And all of that might sound cool, but what about all of these questions? It obviously raises huge concerns about maintaining user confidence, how users will react to change, whether mutations might happen that actually turn out to be unhelpful, and also what happens when two characteristics collide. So for characteristic collision, the example that I got in a question recently was essentially with the contrast mutation. If we have a user that's low vision and they need high contrast all the time, what would happen if the app also makes use of the contrast mutation? And I think the very simple and quick answer to that is that characteristics would always take precedent over behaviors. So if a mutation related to a characteristic was colliding with something with a behavior, the characteristic would override because that's a longer term ongoing situation for the user. Also the mutative life cycle and unhelpful mutations. So it's easy to kind of just say like machine learning, that's the answer, but we have to figure this out in the meantime because we're not there yet. So essentially I think it goes back to ensuring that we research the correct timelines for mutations. And as we determine the mutations for specific components, we would study what rate of change in which direction actually works for users, and hopefully not run into too many low confidence or unhelpful mutations.
I guess you have to use your common sense as well, not just making changes just to make changes.
Right, so it's a good starting point to just say like, yeah, if you're changing the light value, if you're accepting the light value in real time, for instance, like that's gonna be crazy for the user, nobody's gonna like that. And then going from there into fine tuning how, what actually feels comfortable. And last and maybe most important is user aversion to change. So this is a big question that I always get, which is basically, we know that users a lot of times hate change. If YouTube changes its channel page again, I think that I think the site will explode. There have been change.org petitions. They incite a very strong reaction when dedicated users are faced with change. So my answer to that is really just that to map current expectations to future possibilities, I think is to look at this from the wrong angle. The way that UI and UX patterns evolve is not that they happen at once, and there's a long road ahead of both Project Phoebe and mutative design as a concept. A long enough road that as we progress toward a future where technology assists us by actually knowing us, that users' expectations about what UI and UX can do and are responsible to do will change drastically to the point where an interface that doesn't accommodate you will feel terrible rather than just feeling like the normal interface that we get all the time. And there's the rest of the slides on those topics. So moving on, I do want to talk about Helios. This is an app that Francisco and I are working on now to essentially research mutative patterns. So it's an app that will allow us to perform research on these patterns, both how the patterns work individually, how users perceive change, how the mutations interact with each other, how users experience that, and just defining some patterns. And it's built in a modular way so future mutations can be added. And the kind of ulterior motive for this is just to prove that mutation isn't as hard as it sounds, which maybe Francisco would disagree, but I think that this sounds like something that's too much to implement in your app, but hopefully through Selene and in the future through Helios, we'll demonstrate that you can actually do some of this stuff today without too much overhead. And it will come out at an undisclosed date later this fall. But until then, you can check out all of the writing about Phoebe at hello.phoebe.xyz. You can find the source code and all of the open source design files, and you can join the community to join the discussion. And that's it. So if there are any questions.
Your code slide, what was we were passing 250 something, was that an alpha value? That was the milliseconds. Thank you.
In the code.
Yeah, but
Just
bottom right. Slide. Yeah, that's milliseconds.
Please don't change your times
Why?
because if you will measure, for example, if you remember last update with this API call, and then we will change in time, for example, time zone or something, right? You will probably have difference about a few hours, maybe days. There are APIs that are not identified ones.
Sure. If you're interested, you can do pull request if you want to.
Oh, this part is also.
Everything is open source. So just go there and pull request, and I'll work from it.
I think I have a couple design and development questions.
Sure.
So Leon, have you think about this as a solution for like design patterns that works for some users and maybe another user would like to use another, like for example, now we have the bottom navigation, I don't know if you like that, and we have, the original tabs. Have you think about this as alternative, like alternating using tabs and bottom navigation, changing that? I mean, I guess this a change for design patterns or just small elements on the interface?
I think that ideally it should be more component focused rather than switching out what kinds of components we're using, both because if we're making substantial changes, so mutative design isn't meant to obviate the existing design process, basically. So you want to make the best decisions that you can on day one to establish what's in your app, and every time you add a new feature. And so I don't think, both for that reason and because it's very tough to support an app that would be switching navigation paradigms. I think it would cause too much of a challenge, and it would probably decrease confidence since multiple users might compare and say, it works totally differently. So I don't think we would switch things at quite that level. But
So the approach now to is now listening to the sensors of the phone in order to try to make a change in something in the UI.
Just this case, this specific case, yeah, we take the values from the light sensor, the ambient light sensor, and just apply the calculations. And I think that the hardest part was the text color, because text is always the contrary color from the background, or most of the times. So there's a point in the calculation where the text and the background are almost at the same color. So I think that was the hardest part. I think it isn't perfect yet, but it's rare that it happens. But yeah, if you light it changing too much, it can be, both colors can be the same and just stop seeing the text. So it's a challenge as everything else. So.
Yeah. And there's a lot sensors can do, but I also think there's a lot that we can learn from user interaction variables. So there's things that we can know that the user might not be aware of just from their interaction, and things that they might be aware of in their ambient surroundings from the sensors. So
there was an early thing that Liam wanted to do, which was figuring it out when the user was clicking on the display. But I think that's quite hard, because how do we know that the user wants to click that specific button? And we had a couple arguments about that.
Right.
No, good arguments. But yeah, I think that's quite challenging, because we cannot just understand what's in the mind of the user. But yeah, that's probably something to figure it out sometime.
Right, and that, there are complexities when, I said that components could passively accept instructions like buttons and stuff, but we also need to know, are there other buttons surrounding that button? What does that do versus the other things on the screen? Things like that. And if Franco and I aren't arguing at least once a week, I get worried.
Does host is mutated object in database, or is it just an object?
Oh no, this is very pretty, but the mutative object is just a view. So I don't know which view is. I subscribe each view through an event bus, and I just have to figure it out. This is kind of ugly, but to figure it out which type of view that object is. I know I only have this one because I only subscribe this once in this specific case, but obviously something more robust should be like this.
Because I was thinking, because you're saying that mutated objects, like they have certain, this is what I understood, there are like certain properties that would mutate. Say if there's like a mutated object like interface, then you can fix it.
Probably that would be more ideal, yeah, but this, yeah, sure, I agree with you. So don't call like this.
Sure.
So you talked about doing user tests to find what the optimal number of seconds before signifying that somebody was confused before you translated the button to fill the whole screen. Can you talk a little bit about the user testing that went into that? Like, was there like a back-end component that was like keeping time, or was someone just watching and?
So for that specific one, it was really just between us and people that we knew, and it was just watching. And I think a lot of this stuff, and with Helios too, although we might have the ability with that to time in the background or observe certain other things in the background without relying on observation. But I think a lot of research will be observation and also just gauging how the user experiences those things.
And is that kind of how you picked like the helpful mutations, like the types of things that might be helpful, was kind of like observations in your life and other people's lives, things you just kind of wanted, or was there like an algorithm that you used for that, or like what kind of, how did you come upon these ideas and what you wanted to try to use these for your first round?
Yeah, for the first sample app, I had a lot of ideas actually. So it was a balance between, what would, again, have the greatest impact, what was technically feasible, and honestly, what would make a good demo for the sample app. But in the future, helpful mutations would be more based on whether they actually increase the success of the component goals. So whether users are able to use your app well based on those changes or not.
The light thing specifically, it occurred to me when I was walking on the streets, and my country is very sunny, and the AMOLED panels have low brightness on devices like the Nexus 6P, for example, or the Nexus 6. And I was walking down the street and I couldn't see my screen. Everything was. So that just came up, okay, this is probably something that I would love to have on all my apps, even the system, because it really helps on day-to-day life. But there's no other type of tests of anything, just by.
Are there any sensors you guys are looking forward to in the future? In the past, I remember my Galaxy S4 had like a infrared sensor and a moisture sensor, which was awesome. And I don't think I've had an Android since with the infrared sensor. It was fun to turn televisions on. Not that that really especially is. But are there any sensors you guys are excited about or that you wish existed that could enrich what you're trying to do with mutation?
It's hard to say. I mean, personally, I get excited by new sensors all the time. I remember one of the Galaxy phones had an RGB sensor, and I was like super excited about that. But I don't know if that went anywhere. But I am excited by things like Google's Awareness API, even like that can tell us a lot about behaviors and what the user's doing. So yeah, in a general sense, yes. But is there a specific one that I wish existed? Not specifically yet.
I think sensors are just a great way to gather info, so you can just use it for whatever, for the specific.
A barometric sensor might be cool too. You can tell like going up and down, like heights and stuff. You can do different things as you go up and down the road.
Yeah, and I think actually some devices have barometers already to assist with GPS, but they just aren't really used. But yeah, that would be cool.
there's always the problem that I was talking earlier. Every OEM has different implementations, and sometimes they are broken, and it's bad. So when you're trying to do something like this that works on every device, on Android, I think that's a problem. And I had that a couple times, but we live with that. So maybe Google can enforce that better, as all sensors are better calibrated or something. I'm not the one to talk about.
Right. And so I think in general, these first samples are more explorations of what we can do today and just demonstrating the value of these features as we work toward a future where we'll be able to account for things like that. And maybe, assuming that Android stays on top for a while, maybe in the future your device would just be part of a characteristic and it would know to account for those things. Anybody else?
So this is more of a request than a question. So,
Sure.
particularly regarding the text and the icon document, would it be possible for you guys to, for example, create standardized styles that use within our applications? Maybe use an option that way. So if you're using Gaia inside the application, you can easily just switch over to a high contrast mode with your standard guidelines instead.
I would be happy to do that. But
Really? I have no idea, to be honest. I think that's something that we have to talk about a little bit. I really have no idea. I think that having that probably just limits someone else about the mutation. I think everyone should have its own mutations for their own problems and situation, not just use what we are trying to
But
present.
it sounds like a basis to it if you could use it. Maybe not side projects, not maybe our own user projects, then try it out more. Just kind of like using the default material design guidelines from the app pack and taking it in, but then we're filling it on top of yours instead.
yeah, I think it's a worthwhile thing to explore, for sure, because the ultimate goal is to get this adopted and have people using it. So if there's something that makes it easier besides just having the code, then
No promises, I don't know.
yeah, of
But
course.
This is where the arguments come in.
Yeah.
Well, it's a good point, but I have to think about it.
Yeah,
Maybe
no
someone-
ETAs.
Maybe someone wants to contribute, but I don't.
Sure.
Currently, no idea. Any other question?
So when you're changing the interface, like for the contacts app, you sometimes sort of labels when you go to a new user and sometimes you don't. How do you convey to the user why that change is happening?
I think ideally we wouldn't have to.
But like, or I guess also like for when you don't have data, you show the voice icon, voice search, but data you show without data you don't. So the user's looking for that. They don't know data's connected to voice search.
Yeah, that's a good point. It could be that if this went from demonstration to an actual app, that would be something we would have to address, obviously. But
Ideally, your device already knows everything about you. If you're a baby or someone very old.
It's how the user, the device can do something, so it hides it, but the user doesn't know that.
right, so the user might not know that they're having network issues, for example.
But they just don't know that networks related to voice search.
Right. Yeah, and that's a good point.
And it goes into what you said about maybe in the future we would expect our interfaces to change.
Right.
I know sometimes I'll be like, yeah, I get it. Stop showing me that. Or something like that. So maybe I guess just like I'm always clicking on it. All of the extra stuff about it.
Right. So in the interim, that would be something we have to change, but yeah, maybe as our expectations change, that will change as well.
In our defense, that context screens are just screens, are not a real app. So I'll blame anything
It's not
on Liam.
Francisco's fault.
So, but yeah, I think it's a good point.
Right.
Thank
Thank
you.
you, everyone.